Our next session will be led by Kevin Dewalt. He is the co-founder and CEO of Prolego. Kevin has a distinguished career with 30 years of experience as an entrepreneur, engineer, and tech investor. As CEO of Prolego, he helps companies use artificial intelligence to generate billion-dollar revenue opportunities. He is the author of Become an AI Company in 90 Days, the most widely read business book on AI for Fortune 500 executives. A seasoned entrepreneur, Prolego is his fifth tech startup, and he has raised venture capital funds from top-tier firms. At In-Q-Tel, the investing arm of the U.S. intelligence community, he helped make over 25 venture capital investments. He also worked with Palantir founder Stephen Cohen to deploy the company's first AI product in the U.S. intelligence community. Kevin is also an active angel investor and a recognized global tech futurist and innovation leader. He is a founding board member of the SENS Foundation, Peter Thiel and Aubrey de Grey, an organization dedicated to curing the diseases of human aging. As one of the original leaders of the lean startup movement, he helped the National Science Foundation create the iCorps program and launch the first class with Steve Blank at Stanford. Mr. Dewalt graduated #1 in his U.S. Coast Guard Academy class with a degree in electrical engineering. His expertise in AI began at Stanford University while earning his master's degree and completing original research under legend Dr. Bernard Woodrow. Please join me in welcoming Kevin to the stage.
Okay. Sound? How's the sound? Okay, great. Thank you so much. Okay, thank you, everyone, and welcome to Generating Business Opportunities with AI. I'm Kevin Dewalt. I'm co-founder of Prolego, along with my partner, Russ Rands. You may have seen him there in the back. We are a boutique AI services company, and that usually involves things like model development and fundamental research, deploying models, strategy, and training, and developing AI competency among our clients. How many of you had a chance to receive a copy of our book today? We had a couple hundred. Wow, that's it. Yeah, unfortunately, supply greatly exceeded demand. We brought a couple hundred with us. So if you didn't get a copy and you would like one, please contact Russ, my co-founder. He can mail you one. You can also download an e-copy off our website. You don't have to take any notes today. Everything that I'm going to talk about is covered in our book. What I'm going to talk about is a subset of the type of workshops we do with our clients where we help them basically get informed about AI topics. We're a little bit different than most companies in our space. Most of what you read about AI is talking about models and model development and tech, and we absolutely love that stuff. And we love to geek out on all the latest research and all the latest papers. But when we work with our clients, we realize that most of their problems are not related to tech. They're related to organizational change and recruiting and deployment and infrastructure and data, and actually trying to look for ROI and trying to find business opportunities with this technology. And so that's what we're going to talk about today. So by the end of today, I'm going to give you two skills. Like when you go back to your office, I want to give you two things that you couldn't do before. I want to give you first, I'm going to give you some very simple heuristics that you can use as a first pass to identify AI opportunities based on the type of technologies that most companies in financial services are already deploying. And the second skill I'm going to give you is I'm going to show you how you can take those opportunities and you can filter those down and examine them a little bit closer to figure out which ones are actually going to drive return on your business. Okay, so let's jump into AI opportunities. So AI is a fundamental technology. It's like electricity or the internet or the microprocessor, and it's going to create hundreds of billions of dollars of value over the next 10 years, and it's going to destroy hundreds of billions of dollars of value. And all of us are here today because we want to be on the winning side of that equation. In our careers and our companies, we want to be the winners that come out of AI. So all of us are trying to figure out, one way or another, like what business problems can we solve for AI? All of us want to create the next $100 billion business with this technology. But this isn't easy, because 90% of the discussions and the discussions about AI, what people write about and what they talk about, is incredibly arcane and technical. And so it's very difficult to go from a conversation where you're talking about batch pooling and max pooling and convolutional neural networks and try to roll that up into a conversation where you can talk about solving a real business problem. And even for practitioners like us, like people who love reading the papers and live and breathe this stuff every day, we still have to have a way to communicate this technology to our constituents, to our leadership and to our management, and give them some tools for understanding why we're working on these different problems and why these projects are the one we're pursuing and where we're really going to drive value in the long term from this technology. So instead of talking about the fundamental tech, we use a concept we call AI product patterns. And these are unified ways using common practiced AI technology to solve recurring business problems. And I'm going to talk about 4 of those product patterns today. Now, these product patterns, just to warn you, these don't cover everything you can possibly do with AI. There's 100 research papers published every day in machine learning. There's amazing things happening in things like adversarial learning and reinforcement learning and generative networks. I mean, there's tons of great stuff happening. But when the rubber meets the road, and I have to actually sit with a client in a first meeting, and I get a call on a Friday afternoon, or if I'm brought into a new domain where I don't know a lot about what's going on, I rely on these 4 basic tools to filter through and identify at a very first pass what are the ways that this technology can drive value for my clients. So the first product pattern is computer vision. How many people out there are using any kind of computer vision at their companies and any of their applications? Anybody? Show of hands. A couple of folks. Yep, that's about what I expected. Unlike a lot of other domains, we don't use a ton of computer vision in financial services. In transportation, logistics, defense, there's tons of computer vision in those spaces. We see some use of it at some companies. So computer vision is the domain of trying to make sense and understand what is happening in a digital image. Okay? And it's a really complex, interesting research problem that vexed researchers and computer scientists for decades. And so for decades, researchers would have contests like this one here, cats versus dogs. And they would give a bunch of computer scientists a pile of images and say, hey, try to figure out, build an algorithm that's good at predicting if this image contains a cat or a dog. And as of about 2013 or so, computers could do this with maybe 80, 82% accuracy. And in the last couple of years, with these deep learning frameworks, with convolutional neural networks, this is now a trivial problem. And anybody in a few minutes, even if you know nothing about machine learning, can download some simple algorithms off the internet, and you can get 95% state-of-the-art accuracy at predicting this kind of problem. This is mostly solved. So computer vision has evolved very rapidly, and it's one of the earliest ways that deep learning and AI made a big impact in the enterprise. Some examples of how you can use machine or computer vision in your organization: classifying images, identifying what is the object in an image, image search, retrieving an image from a data set, image restoration. We see a lot of this in retail. We want to clean up an image to make it look nicer for a product sale. And as anybody that has one of the modern iPhones can tell you, biometrics and facial recognition works incredibly well now. So to give you a sense of how rapidly the state-of-the-art is changing in this domain, I really like this example. This is actually, I think, about 18 months old. It's a project that came out of Google Labs. And Google was trying to figure out how could they teach an algorithm to learn about objects in an image. And what I love about this example is that Google tried to teach an algorithm to identify whether or not a particular object in this image is a person or a kite. And they assigned probability scores to each one of these predictions. Now, some of these are pretty obvious. Like you look in the lower left-hand side there, those are obviously people, and the algorithm does a pretty good job of making predictions of high confidence scores, and that those are people. And if you look at the upper center of the page, you can see with about 99% accuracy, the algorithm knows that this is a kite. But what about on the far right-hand side of the screen? There's a couple of blips of pixels, and they're kind of blurry, and they're not easy to figure out. Why is the algorithm so confident that blob there is a person and that other blob is a kite? Anybody take a guess? How does the algorithm know? Go ahead. How? Yeah, the algorithms figured out context. They figured out that kites are in the air and people are in the water. And so, I mean, and this isn't even the latest state of the art in this domain, but it's getting very, very intelligent at not just understanding what's in an image, but learning all the context around it that helps it to understand how to make a decision. So as you look in your organization, you want to try to find opportunities for using computer vision at your companies. If you're already using images, then most likely some of your data science team is already looking at some of these techniques for using advanced computer vision as part of your business. More often, we see companies, especially in financial services, that are trying to add images to some existing product or some existing workflow. So if you work at an insurance company and you have people submitting claims, especially in automotive, maybe you have customers that are taking a picture of an automobile, and now there's companies that are training on these pictures to try to determine, okay, was this really an accident as the person described it, or did something else happen? You're going to hear me talk a lot today about training data. And if you haven't spent much time doing machine learning, one of the biggest cost drivers of doing anything in machine learning is the cost of building training data. And that is the data that you're going to use to teach the algorithms to do what you want them to do. And in computer vision, that typically relies on people going in and hand labeling data. So if you want to teach an algorithm how to identify whether somebody's wearing a hat or not, you have to have people go in and actually look at pictures and say, yes, it has a hat, or no, it doesn't have a hat. Fortunately, this has gotten a lot easier in the last couple of years. There are algorithms out there that do a good job of helping you automate some of this, and there are lots of third-party companies you can hire to help automate. But nonetheless, if you're thinking about doing any kind of computer vision problem, you're going to have to look at some degree to make some investment in labeling data. Okay, so that is computer vision. The second product pattern I'm going to talk about is natural language processing. And this is actually my favorite when I talk to financial services companies. Natural language processing, or NLP, is a domain of trying to understand or generate human-generated language data, which we call sort of natural data. It's the things that all of us speak, write, type, chats, emails, text, spoken words. There's two reasons why I really love talking about NLP data with financial services companies. The first is that we have so much natural data in our businesses. How many people are working on NLP projects in their company? Okay, yeah, it's probably about 5 times the hands of computer vision. And that's because we have so much text data, right? We got all the chats with our customers. We got emails with our customers. We got all of our customer service reps that are on the phone talking to people all day long. We have our policies, our contracts, our internal emails. We have our 10Ks, 10Qs. I mean, natural language is everywhere in financial services. So the second reason I'm so excited to talk about it is this is the domain that's advancing so fast. And if you look at the published research and what our customers are doing, what's happening, the techniques for doing this with less data, doing it faster and more accurately, are advancing almost on a day-by-day basis. The NLP right now is where computer vision was 5 years ago, so it's really an exciting time. Typical examples of using natural language processing, I'm not going to read through these because I think most of you are probably familiar with a lot of these use cases. The classical ones are machine translation, text generation, text categorization, chatbots, sentiment analysis. You've probably seen a lot of these talked about in your businesses. Actually, I think what's more interesting to talk about is how you're going to go and identify opportunities for using NLP at your companies. And so what we see most of our clients doing is they're just looking at their business and they're starting to ask questions. So looking at every place where they have text data and they're asking things like, what if we could quickly categorize this customer email or this document? What would that do with our business? What if we could take all the time that we have our lawyers that are searching through claims and searching through contracts, what if we can make it easier for them to search for the key provisions that they're looking for? How much business value would that drive? What if we could automatically look at our customers' chat conversations and identify those that are at highest risk for churning or quitting their account quickly? And normally what most of our clients find is they come up with dozens of potential use cases. And usually those that filter to the top of the pile are those where they have the strongest relationship with the business customer and the data is most ready. So I think if you start asking these type of questions in your organization, you're going to find tons of opportunity for NLP. So developing training data for NLP is typically harder than doing it for computer vision, is for a simple reason. It's a lot harder for people to read and understand a text in a document than it is to look at an image and identify what's happening and what's in it. And often you need to have domain experts if you're going to develop a corpus of training data to train your algorithms. You might need your lawyers or some of your experts that really understand what's in these documents to correctly categorize them for you. Fortunately, over the last year, this has gotten a lot easier. And 18 months ago, you had to have Google and Baidu money and scale to really do a lot with NLP. Now there are transfer learning techniques and models that you can get off the shelf that have often pre-trained that you can very quickly put into practice and figure out, do we have an application that's going to work? Okay, the third product pattern I'm going to talk about, and the one that comes up also a lot in financial services, is what I call next-in sequence predictions. Some people call this tabular data, some people call it structured data, but it's basically data that's sitting around in your databases. Okay, and in financial services, we got a lot of data. We got a lot of data in databases, CSV files. So situations where you might find an application for next in sequence predictions are if you have IoT devices, maybe you're deploying some IoT devices to your customers, your data centers, like the events they produce. All of your sales and marketing data, the marketing data that's in Salesforce or Marketo that's in a structured format. All your online user behavior, if you're tracking what users do online and look at what pages they went to, where they go, what they bought, all that's usually stored in databases, or things like server logs, which are sort of usually semi-structured. Lots of applications for taking database data and structured data inside financial services companies and using machine learning. Predicting future sales based on past sales, classifying a log entry as maybe an anomaly or a critical system error or hack, credit card fraud, looking at remote sensors or IoT devices and looking for anomalous events, or predicting which users will buy, market segmentation, lead scoring. There's tons of all kinds of business applications for next in sequence. When I talk about structured data for our purposes, I have to put this out there because if you've ever been in a conversation with data scientists and you start talking about structured data, you can get in near religious arguments about what actually is structured and unstructured data. But for the purposes of this conversation, I'm talking about things that appear in a database. So things like sales data, dates, times, not things like entire documents or images. Those are usually stored in a file system somewhere. So how to identify next in sequence opportunities in your organization? The first way we recommend is look at what your business is doing today. Like look at what your company is doing. How are you using data? Where are you making predictions inside your organization? What is this particular unit doing? What is this particular group doing? How are they trying to predict sales forecasts? We're marketing and trying to segment to different customers. Look at how you're working today. The second way is to look at your KPIs. Look at your key performance indicators. What is your business measuring? Now, everybody's trying to measure revenue and costs, but most businesses are also measuring things like how long does it take a particular process to run? What's the outcome of this particular business process? How long does it take us to close a sale? How long do accounts stay active before we see customer churn? How many times do we have to touch a customer before we make a conversion? There's all kinds of opportunities to look at your existing metrics and look for ways you can use machine learning to drive them faster. And the final way we see it is that there's always new data sources and new third-party vendors that are producing data sources. And as you start seeing those come online, be creative and think about ways that you could apply weather and credit scoring, credit scores, commodity pricing, geospatial events. Now that we have climate change, there's companies that are producing data about what's going to happen in the world. Different ways you can use these new data sources to generate value in your business. Training data for next in sequence, we don't usually have to do a lot of data labeling. Usually the labels you want are already resident in your database, but what you probably have to do is a lot of feature engineering. So typically when you would ask your data science team to go make a prediction or try to build a model that'll make a prediction using data in your databases, they'll come back and say, okay, we have to do a lot of feature engineering. And that just means they have to spend a couple of months taking the data that they have and trying to derive aspects of it that are going to be correlated with what they want to measure. So as you think about the projects when you're talking about doing something in a next in sequence application, just bake that time and that investment into whatever you're trying to test. And the final product pattern, and the one I'm going to spend the least amount of time talking about, are collaborative filters. And collaborative filters are normally found in recommendation engines and sometimes online campaigns. The best way to describe them is with an example. You use these in a domain where you have a lot of different users and you have different behaviors of those users, such as purchasing products, and you want to try to identify complex correlations between these different events so you can figure out what is somebody going to do, or what can I sell that person. And I can best explain this with an example. So the Netflix recommendation system, at least the traditional ones and some of the original contests that they use to try to generate the recommendation system, use collaborative filters. So when my wife and I sit down to watch a movie on a Saturday night, she grabs the remote control and she starts flipping through Netflix and says, okay, what are we going to watch? What are we going to watch? What are we going to watch, right? And at some point, she's going to stop and look at something, and it's probably a rom-com, right? And at that point, I start throwing a temper tantrum. I know rom-coms. I don't want to watch a rom. I don't want to sit here for 3 hours and watch a freaking rom-com, right? Unless that rom-com has Vince Vaughn, and then I will like to watch the rom-com. But it's really hard for Netflix to go build a complex rule system that says, okay, this, Kevin's won't like rom-coms unless they have Vince Vaughn in it. Like developing all those edge cases is almost impossible without using some sort of machine learning technology. But if you imagine that there are probably a lot of other middle-aged married guys like me who watch the same kind of movies that I like, who don't like rom-coms but do like Vince Vaughn. And if you look at all the past behaviors of people like me and look at the things they liked, you can find correlations in them. And collaborative filters give you a simple, quick, off-the-shelf way of building recommendation engines, looking at what other people have done. So these models don't have to act as standalone, and quite often when we start doing projects with the clients, you can start combining these models together. So when I first started looking at some of these modern deep learning libraries a couple of years ago, and I saw people taking things from text and images and kind of mashing them all together in a neural network, I thought this all looked like hocus pocus, right? Because in software engineering, it just is never this easy. Like software engineering is always tough, and it's very difficult to combine things together. But these neural networks are just mathematical models that make predictions, and they all are fed and release data. And you can actually combine different models using different types of data and combine them together to make some sort of combination or prediction. Okay, so that is the basics on the 4 product patterns. And again, this is not nearly the domain of everything you can possibly do with AI. We're doing adversarial networks and generative networks and reinforcement learning and inverse reinforcement learning. We're doing a lot of cutting edge stuff with our clients. But when I'm at the beginning of any kind of project, any kind of relationship, I go to these 4 product patterns all the time because it's the fastest way to triage and quickly think about, is there a viable, quick business opportunity here for the client? Is there a quick win? Because all of us, when in any kind of work in AI, we're all looking for a quick win. But at some point, just identifying some sort of product pattern isn't enough. You have to take it to the next level. And you have to start thinking, okay, is this the right thing for me to invest the company's money in? Can we really make any money in this? How much time is it going to take? Do we have to push the state of the art? Do we have the data? All these questions started surfacing. And over time in working with clients, we started seeing patterns to the type of questions they were asking about regulation and models and data and governance and tools. And these recurrent themes started coming up. So we developed what we called the AI canvas. How many people have heard of the business model canvas that Alexander Osterwalder used, or lean canvas by Ashmore? Anybody use any of these? Okay, great, yeah. So very similar to these type of tools. Canvases are frameworks that help you organize your thinking. They don't answer all of your hardest questions, but they help you lead and know what questions to ask. And that's how we use the AI canvas. So it's designed to help you look at a bunch of different AI use cases and triage and figure out which are the ones that we should be investing with first, or which ones should I recommend. It's also excellent for team communications, and it's great for executive briefs, because when you can sit down across from your boss, your leadership team, or your clients, and you can plop an iPad in front of them and point to each one of these blocks and explain why you're going to work on something, it makes it a lot easier to have the conversation. So I'm going to walk through it real quickly. Does anybody have an example, something not too complicated, maybe based on one of the 4 product patterns that we started with, that you'd like me to use to go through the AI canvas? Anybody want to, before I use a suggestion, anybody have one they want me to use? Something from work? Go ahead.
Using Salesforce data
Mm-hmm.
to optimize how to optimize closing rate on business by looking at that chain of events.
Okay.
To see which way, when you're at one point, should we go this way or that way with that client? Potentially.
Got it. Okay, so you've got a Salesforce database, and you've got a history of client behavior. Maybe is it online or offline, or it could be all kinds of actions? Oh, I downloaded some, met them at a conference. It's got all kinds of events in Salesforce that track where they go, and you want to have an algorithm that's predict what's the next content event that we should put in front of this customer to accelerate close.
Yeah.
Okay.
Should we call them, or should we
Yeah. What next event? Next event to drive action. Yes, love it. Excellent. Very common use case. Okay, so everybody understand that? So I'll go through the canvas, right? So here's the opportunity. So the opportunity here is you close cases faster, right? So if you can develop an algorithm that allows you to predict what you should do next to close a client, then you're going to make more business. You're going to close cases faster, drive higher revenue. Salespeople get more commissions. Whoo, everyone's happy. So they got it there? Okay. So that's the opportunity, starting on the left. So the canvas, like I said, is divided into two parts. The left-hand side has the business part. The right-hand side has the technical, and it gets easier at the top, and it gets harder as you work your way down the page. So let's go to the second block, then the consumers. So opportunity is easy, right? Solution's easy. But all of these technologies that we build, they have to be consumed within our environment. So if you're going to build a model that's going to tell you what action should you take next to drive a purchasing decision, that model is going to spit out a score or an event or a number or maybe or an action inside your database, and that has to go somewhere. It has to go to a system, and it has to go to a person. So let's think about what has to happen for that to work. So you've got to figure out a way to take whatever that model outputs, and maybe it's going to write back into Salesforce database so that maybe your sales team can look at it the next day and say, okay, next action is Jack, you're going to call these 3 people, and John, you're going to send a follow-up email. So that this one's a little bit easier on the technology side. Where this problem is harder is on the human behavior change side. So part of the consumers that has to happen is that the sales team has to change their behavior, and they have to start looking to work differently and to start relying on the results of the data. And we've seen this challenge happen a number of times with our clients. Salespeople tend to come in every day and work the same way and call the people at the top of the list. They have a very rigid way of working. It can often take a lot of working with them to get them to change their behavior. So that's an example of the type of way we'd use the canvas to identify who are the consumers of the model and what has to change. Strategy, why us? So why should you build this in-house? Why not just wait for some third party to come out with this type of tool and just buy it off of them? And if I was making the case for this type of tool, I would say because our products are unique, our sales workflow is unique, and sales is so important to our business, we want to have control over this workflow. We don't want to just use some random third-party product. We want to own this and be the best at it because it's a strategic asset for us. Policy and process. You have to ask yourself, what else has to change? Do we have the rights to this data? Do we have to change our end user agreements? Do you have anything in your Salesforce data about your customers that you would feel a little bit creepy about using in any kind of machine learning model? Is there information in there that if it got out in the front page of the New York Times, you would be a bit of embarrassed to know how people are using it? So typically the kind of things that have to change. In this case, Salesforce, probably not. You're probably pretty safe there. You probably own most of the data. It's probably entered by your sales team. Going down the technical side, what's the solution? Okay, well, the solution is we're going to build a model using the next-in sequence product pattern, most likely, to make a prediction about what action a salesperson should take. Data sources, what are the model inputs? Well, you probably have your Salesforce data, but you might also have maybe some unstructured data in customer emails. Maybe you have some other, you possibly could be looking at online behavior, maybe social media, other information. You might have third-party sources, Clearbit, you want to use to enrich the data, to learn more about the customers, learn the demographics from firmographics about them. So all the different data sources you could pull in, you want to capture that here. The model development, how are we going to build it? Fortunately, this is pretty straightforward. This is the kind of thing you could download off of PyTorch or scikit-learn, and your internal data science team could build. So you don't have to do any kind of fundamental research here. And finally, and last but not least, and the one that is often hardest, is what are your success criteria? How good is good enough, right? So you're going to have a data science team. They're going to be working on this. They're going to be pulling in data. They're going to be writing things, deploying it. There's going to be a cost associated with this. How good does it have to work before that it works, it is good enough? So I'd imagine you could set up some metrics like, hey, our average closing time takes 65 days, and we can improve that by 5%. How much does that move the needle in our business? Some sort of metric like that. So anyway, that is the AI canvas. This is exactly how we use it with clients. And like the product patterns, it serves as a great first triage to figure out, kind of looking at lots of different opportunities and figure out which ones you could work on. Okay, so I said I was going to give you 2 skills coming out here. So the first skill I gave you was the 4 product patterns. Somebody shout out one of the product patterns. Next in sequence, NLP, computer vision, and collaborative filtering. Excellent. Okay, so you know those 4 basic product patterns you can use to triage. And we talked about the AI canvas, which is the first pass you can use in trying to vet whether or not an AI use case is a potential business opportunity and try to wrap your arms around it. Okay, so those are the 2 skills I gave you. I have a quick favor I'd like to ask of all of you if you found this helpful. We could use some advice. The biggest challenge we are currently seeing with our clients right now is they're asking us, what are other financial services companies doing with AI? The tech stuff is not a challenge. They want to know, how are people deploying models? How are they hiring? How are they doing organizational change? And how are they integrating? And so we are exploring the option of creating some sort of membership organization so people in financial services can learn from peer companies how to solve these kind of problems. So if you have any advice, thoughts, or opinions on this type of service, or you'd like to give us any feedback, please contact Russ Rans, my partner, or myself. We would love to hear your opinions. That's it. Thank you very much. I hope this was useful.
Thank you so much.